Testing. Testing.
Good day once again. Today we're looking at matrices 2, as we mentioned before, and we're looking at determinant, we're looking at adjoint, and we're looking at inverse of a matrix. So the first one, it says given A equals 3, 4, 6, 7. So the first thing I'm going to do is find state the determinant formula. So the determinant of A is AB minus BC. We know that A and D are the leading diagonal, which is that one. So it's going to be 3 times 7 minus the non-leading diagonal, which is 6 and 4. So 4 times 6. So we have that the determinant of the matrix is 3 times 7, which is 21, minus 6 times 4, which is 24. So the determinant is actually -3. Since the determinant is -3, then that means that this is a non-singular matrix. Non-singular matrix, right? Any questions with A? Any questions with A, guys? So the next part is B. And in B, we're looking for the A adjoint or the adjoint of A. Same thing. And so that's going to be D negative B negative C A. So all we're doing is we're changing the leading diagonal. We're reversing the leading diagonal. And we're changing the signs of the non-leading diagonal. So since 3 and 7 are the leading diagonal, it will now be 7, 3. And then for my non-leading diagonal, since both of them are positive, then I will change them into negatives. And that is all that I have to do for adjoint. Okay. So for the third part, C, we are looking for what is called the inverse of A. And the inverse of A is 1 over the determinant times the adjoint of A. So that's A to the -1 is 1 over the determinant. We found it to be -3. So 1 over -3 times, and I'm going to put the adjoint that I calculated. So 7, -4, -6, 3. And I'm going to multiply, scalar multiply that. So it's going to be A to the -1 is equal to -1/3 times 7, -1/3 times -4, -1/3 times -6, and -1/3 times 3. So that means, now remember, if I can't cancel it out, then all I do is leave it as a fraction. So here I have a negative times a positive, that's a negative. 7 cannot be cancelled with 3, so it's going to be 7/3. Negative times negative is a positive. I don't need to put the positive sign, I'm just emphasizing. And again, the 4 cannot be cancelled by the 3, so I'm just going to call it 4/3. Here, a negative and a negative, I know it's a positive. Again, you don't need to write it. I am just emphasizing. But this 3 and the 6 can cancel. 3 into 3 is 1 and 3 into 6 is 2. So here I'm going to have a positive 2. Similarly, here, -1/3 times 3, well, the negative and the positive gives me a negative. And the 3's cancel, leaving me simply with 1. So hence that is my inverse right there. So A to the -1 is equal to the matrix of -7/3, 4/3, 2, and a -1. Question.